Today, still in systems, but moving a little further down here on page 4 to where our next pile of blank is. And we're going to be dealing with word problems. And we got 3 types we're going to deal with. So the first one is going to be what's called a break-even point. So if you ever decide to go into business for yourself in any way, the break-even point will be important to you because that's where how much money you're putting into the business and how much you're selling are even, and then we hope to get above that where we're making profits. But for our purposes, it just means that our costs equal our revenue. So what does that mean? So let's see. We're going to open a new business grooming dogs, okay? You buy the equipment for $5,000. Be a cost, okay? That's an upfront cost that you have. It costs you, more costs, $5 in products for each dog you groom. That's also a cost. Then you charge people $30 for each dog. That's your revenue. Another word for revenue sometimes is sales. So you pay $5,000 up front. And you also pay $5, every time you see the word per or each. That's an X, because that means whether you groom 1 dog or 50, you're spending $5 in products each time. So when we see that each value, we've got to put an X with it. Okay? You bought the equipment for $5,000. I don't have to do that every time. I got to do that once. That's why that doesn't get an X. So my costs are $5,000 plus 5X. My revenue, I'm getting $30 for, there's that word each again. $30 for each dog. 30X. And so when we're doing a break-even point, if cost equals revenue, then when I go to make my equation, cost equals revenue. Okay, and the good news here, I don't have 2 variables I gotta solve for. Hallelujah. And so I go and I do all my normal stuff. Now this is just me. Whenever I see a problem where I have X on one side and it's all by itself, that's where I want to move all the X's. I really don't want to move the 30X to this side because then I can run into problems. So I would say opposites, always got to do opposites when they're on opposite sides here. And then we're just going to divide both sides by 25 because and once we're down to the end, okay, we'd have to groom 200 dogs to break even. If we do less, we lose money. If we do more, we make money. But that's kind of the point of no return. So anytime you see break even show up, you're going to take your cost and your revenue, or your cost and your sales, you're going to set them equal, and you're going to be off and running to the races. But that's it. No Y to have to solve for, which is nice. So as we flip over, okay, a little different this time. So I start to look, and I'm like, okay. So it says we're going to do an equation for the number sold and an equation for the money we've made. So let's see here. In one day, a store sells 300 video games and DVDs. Let me read through this first. They sell video games for $25 and DVDs for $15. The store made $56.40. How many of each did the store sell? Okay, we got 2 variables this time. So I'm going to make my video games V And I'm going to make the DVDs D, just because that's easier for me knowing which one's which than using X and Y. You could, though. So, numbers sold. Okay. In one day, store sells 300 video games and DVDs. So my video games plus my DVDs are going to equal 300. That's strictly on how many I sold. They kind of give me the hint with the word sells there. So video games plus DVDs equals 300. Then I go to the next sentence. They sell video games for $25 each. So money made. $25 for each video game. Money times the number of them. And DVDs for $15 each. Plus 15D. The store made $5,640. In other words, depending on how many video games I sold at 25 a piece and DVDs at 15 a piece, it's going to add up to 5640, but the total number of those two is going to equal 300. This time it's going to be a little different than the first one. This one, I'm just going to put ones in front of these so I can remind myself of that. Now we're going to go back to what we were doing when we were solving our systems of equations. We would like it if we could just add down and eliminate a variable. But that's not going to happen right now. 1 plus 25 does not cancel. 1 plus 15 does not cancel. So we're going to need to multiply one of our equations. Why am I choosing the top one? Is it just random? No. Because we always look where the smaller number is. So here's the question. I'm starting with 1. I want to get to 25. What do I have to multiply by? 25. But I have to multiply by negative 25. You're like, okay. Because if I just did plain old 25, that'd be 25b, that'd be 25b. That's not going to cancel. That's going to give me 50. So instead, by multiplying by negative 25, and that's to everything, every last one of those, okay, make sure that negative 25, the V, the D, and the 300, signs and all. And we're going to leave the other one alone. Because now that I did that multiplying through, now if I go to add straight down, negative 25 and positive 25 cancel. That's the idea. Negative 25 plus 15 is negative 10. And I got to look this one up because, okay. So negative 7,500 plus 5,640 is where that negative 1,860 is coming from. And since we're multiplying by negative 10, and you will get positive numbers on this. I can't sell a negative number of DVDs or video games. So I sold 186 DVDs. But I'm not quite done yet. So I multiplied that across. I got my answer. I have one piece left. I don't know how many video games I sold yet, but the good news is it ain't going to take me anywhere near as long as it took me to find the DVDs. Because I'm going to go back to that very first equation right here, and I'm going to start writing across until I get to the D, because I know how many DVDs I sold. So we're substituting into that top equation. And usually that's going to be the easier equation of the two, which is why we probably picked that. This is where I've got to stay organized and number my steps. You know, I did my multiplying, that's step 1. I did my adding, that's step 2. Now step 3 is the substitution. So I plug that in. And do my one step to see how many. And always label on these so I know that you know which one is which. Don't just put 186 and 114 because, again, that can make a difference on how much money we're making or losing. And if you really wanted to be sure they were right, you could plug in the 114 and the 186, and it will come up to 5640. So, same 3 steps we were doing before the elimination, just kind of adjusting a little bit as that goes. So, one more that's kind of similar. So, we've got Chase and Sarah went to the candy store. Excuse me. So, Chase bought 5 pieces of fudge and 3 pieces of bubble gum for a total of $5.70. Sarah bought 2 pieces of fudge and 10 pieces of bubble gum for a total of $3.60. Write and solve a system of equations to determine the cost of 1 piece of fudge and 1 piece of bubble gum. Okay. This time, they at least labeled the things for me. So I know bubble gum is G and I know fudge is F. So I start going along here for Chase. So like, all right, Chase bought 5 pieces of fudge. I'm just thinking for a minute. Okay, I got it. I don't know, brain cramp there for a minute. 5 pieces of fudge and 3 pieces of bubble gum for a total of $5.70. So then Sarah bought 2 pieces of fudge and 10 pieces of bubble gum for a total of $3.60. So again, a little different way of looking at it. Because this time we just took each individual person and gave them their own equation instead of doing one for the number and one for the money. So again, it depends on what we're given. So now, this gets a little more interesting. Here's a new thing that we're going to run into with this. So I look and I go, okay, if I add down 5 plus 2, that don't go away. 3 plus 10, that doesn't go away. Well, what the heck? Oh, it must be that one that I have to multiply. So you start to think about it, and you're like, okay, so 2 times what's going to get me to 5? Oops, not divide. And you're like, wait a minute, I can't do 2 times something and get to 5. Well, unless it's a fraction or a decimal or something. So I'm like, okay, maybe it's the G. So I start doing that, and I'm like, no. Well, crap, that doesn't work either. Is this just like no solution or something like that? No. Here's the new trick we're going to do. If I can't add down, or if I can't multiply all the way through, here's how this is going to work. we're going to multiply both equations. You're like, okay, so if we're going to multiply both equations, what are we going to do? We're going to take that first number on both of these, and we're going to flip them. So the 5, we're going to move down to the bottom equation. The 2, we're going to move to the top equation. And we're going to do one other thing. I'm going to make one of them negative. Because again, if I did 5 times regular 2, that would be 10. 2 times 5 would be 10. 10 plus 10 doesn't equal 0. That doesn't help me. So again, the idea here is you're just taking those first 2 numbers that you see, the 5 and the 2, and literally just flipping them around. So once I do that, we got some multiplying to do here. Again, the calculator can be a very helpful thing as you're doing this. Distribute your 5 through to everything on the bottom. Now, are you going to have to multiply everything through like this every single time if it's a problem like this? No. No, this is kind of like a special case kind of. And so I get to here, and once I can see, okay, now I see why we flipped those and why we made one negative. You could have done it at the 5 too. Either one will work. But when I get here and I go to add down, okay, the negative 10f and the positive 10f cancel. That's good. That's what we want. Negative 6 plus 50 is 44g. Watch those signs. And negative 11.40 plus 18 is 660. And now we're down to our one-step equation. So I find out a piece of gum, my G, is 15 cents. You're like, dang, we can get decimals and stuff now? Yeah, I mean, this is real life. Not everything's just in dollars. We have some cents as well. And then again, I get into my last part, which is to take that original first sentence, the one that I've got in green up here, and I just start copying it until I get to the variable that I know. And I know that G is 15 cents. So we do a little elimination, a little substitution, and a little equation solved. We did a little of everything with these. And now we're back to regular old equation solving. Again, opposites are key. One of the things I saw in the quiz, for those of you that were kind of rolling, setting things up pretty good, but then having some issues, just simple things. You know, like you to add 45 to both sides. Like, oh, everything else was so good. So just take your time with that stuff. We get to the end. So that one took a little patience. But like I've said before, and I'm going to keep saying, even if I got to be a broken record, if you keep the examples out so you can find the similarities, the setup and the details within the problems are going to be very similar. But it's not just a push button thing. It's not like you go to an app, you click a button, and it's done. You got to think a little bit. So again, we don't want these to go very far away because they're probably going to come in pretty useful when we get into the practice part here. So don't put them away. Just kind of tuck them to the side. And what we're going to do here momentarily is we're going to jump into the practice, kind of get set up on a couple of these, get ourselves rolling a little bit. And we should be pretty decent. And if we need to borrow these from me for something, that's okay. All right, quiz 2 packet. Confession time. They ran my packet the same way they ran the first one. So, like, oh, not again. Yeah, I'm going to have to be down there with them. Howdy, thank you. We got a new packet in the back there if you haven't gotten that. And we're going to go through one last time. I'm going to walk through this with the copy room next time. We're going to number our pages quick. So starting on that very first back of the page, we got 1. So all of our right pages are going to be even numbers. And our left pages are going to be odd. Like me. Definitely odd. And when you get to the end, probably shouldn't say that until I'm there. When you get to the very back, we should be at page 10. Because the back of that last page is blank. So if you've got something besides 10 as you were going through, that is going to be a small bit of an issue. So my biggest word of advice as we start to look at, bless you, as we look at these word problems today, is before you jump in, look them over, see if you can tell which type it is, and then just have your notes there ready to go. So like, all right, let's see what we got here. For his parents' anniversary party, Juan is considering 2 different venues. Prairie Street Brew House will cost $669 for a reservation plus $27 per person. Duh. Lino's will cost $178 for the reservation, $28 per person. How many people would have to attend in order for the cost to be the same? The same. Let's see here. So break even. Another word for break even, cost versus revenue would be the same. Here, okay, this is going to be a break even problem, like number 1 was in the notes. So let me help get this set up. And then I want to go through on a couple more and just help you kind of see what to look for so you know what example is going to be helpful, because that would be something that's kind of important here. So, okay. Cost for the brew house. Let's do this. Prairie Street Brew House will cost $669 for the reservation. I only got to do that once. That doesn't get a variable. Plus $27 per person. Every single person costs $27. So there's my variable going with the 27. Lino's, we do the same thing. $178 for the reservation. $28 per, there's per again, person. And so when I look at my notes, if I'm looking at the break-even problem, I'm like, oh, I'm just going to take those two things. I'm going to set them equal. And I'm going to solve this for the one variable that I have. This is the only type of question that you will have one variable that you're solving for. And then I solve it. And I go about my business. So I keep looking through, and I'm like, okay, pizza, can we tell somebody was hungry when they were making this? Okay. A large pizza at Papa John's costs $6.80 plus 90 cents per topping. A large pizza at Massiano's costs $7.30 plus 65 cents for each topping. How many toppings need to be added to a large pizza from each joint in order for the costs to be the same? Another break-even problem. Another, the two sides are equal, just like this one. It's those little key terms and words that we've got to look for to see that. And you're like, wait a minute. Even on the rest of these, break, even, break, even. Every one on this first page, set the two equations equal, go about your business. From that short little sentence that we're looking at there, or that little phrase. But once you flip over, now it becomes a little different. You can even see it says equation 4, equation 4. So I look through, and I'm like, okay, what's this look closer to? Well, Ron sold tickets to a game. Good seats were $5 each, and poor seats were $2. 210 people attended and paid $6.60. Write a system of equations to be used when we find good seats and poor seats were sold. So I'm looking, and I'm like, to me, that looks a heck of a lot like example number 2. But let's see. So if we do, so we got poor seats are P, good seats are G. So the first one, we had 210 people attend. So our good seats plus our poor seats equals 210, because I'm just strictly looking at the number of tickets, nothing to do with money. So 5 has a dollar sign, so I want to use that in the money equation. 2 has a dollar sign, I want to use that in the money equation. 210 doesn't. That's why that's going here. 660 has a dollar sign. All the things with dollar signs are going to go together in whatever equation that is. So I look and I go, okay, so good seats were 5. 5G. Poor seats were 2. 2P. And we paid $660. All the money together, all the non-money together. And then I'm going to have to multiply my top equation like we did here and go about my business and do my solving. So you kind of can start to see where I'm going with this, what I'm trying to see. So let's do one more. The Thorpes bought 6 hamburgers and 3 orders of fries for $19.50. The Mox bought 3 hamburgers and 2 orders of fries for $10.50. Write a system of linear equations to be used to find out how much 1 hamburger and 1 order of fries cost. So I start to look at my examples again, and I'm like, how many did each of the stores sell? Write and solve the cost of 1 piece of fudge and 1 piece of bubble gum. 1 hamburger, 1 order of fries. I'm pretty sure that's it. So I'm going to use example 3 as my helper. And so I do it one more time. I go, okay, Thorpes, 6 hamburgers, 3 fries, $19.50. Everything is there in one sentence. Again, if you like colors, I got colors in the back. Try and find some more even. The Mox sentence. The Mox bought 3 hamburgers and 2 orders of fries for 1050. Now, here's one thing I will say. Sometimes we get too locked in on following exactly what an example says. You're like, oh my gosh. So this is the one where I got to switch the two numbers in front. So I got to do this by 3 and this by 6 and make a negative. You could. That'd be fine. But if I take a minute and I look at the h's, could I multiply 3 by something to get to 6? Yeah. So to be honest, all I would have to do is multiply the bottom one by -2 to make the h's go away, and I could. But would it be wrong if you did the top by 3, or -3, and the bottom by 6? Not at all. You'd still get to the right answer. That's the cool thing about math a lot of the times. There's multiple ways to get there if you use the tools and you get used to using them. There would be anybody in any trade would tell you the same thing. You know, you may have a tool for one thing, but it may work for multiple things. And so that's kind of cool sometimes. So get those set up, keep trying them out, but put forth that effort to try and get through these. There's only 7 problems total. We'll rotate back through this as we go, but give yourself that best chance.